As I was discussing, the major first part is the choke valve, that is here, that we have simulated, and then after that choke valve, all these tripod, hexapod, octapod, or the 10-pod wellhead platforms, all of those platforms they'll be having the same symmetry. So basically it will all of them will be comprising of the wing valve, then comes the choke valve, and then all of them go into a main manifold, that is the production manifold. There will be a bypass out of the production manifold from every individual wellhead that will be going to the test meter. That test meter basically determines the physical properties like the density, gas oil ratio, and all those things in that particular line. It can be the Coriolis meter or some other meters. It can be the multi-phase flow meter. Those are used for the physical property measurements, and you will come to know that how much sand, how much water, how much oil is coming out of the stream or the pipeline. And then all these main manifold, they'll be going to a one main line, and just when the main line ends, there will be an isolation valve that is known as the ZV. That is known as ZV, that is having certain connection or instrumentation with the ESD panel. Basically it drives in the case of overpressure case scenarios, so this ZV will help you out in the overpressure case scenarios. And the two other parts of the oil wellhead platform is the your drain system and your chemical injection system. Drain system is basically used in case that there is a spillage or the maintenance going on and you want to relieve the inventory into the drain system. That drain system will absorb and that will collect all the losses that are coming out of the pipelines. Another basic purpose of the drain system is that there are so many open tunnels, though the storm run of water that passes through them, and that will all go into the drain system. Chemical injection system is basically used just to inject the chemical into the pipeline just to avoid the corrosion phenomena. So basically all these 4 or 5 systems. So number 1 is the wing valve, number 2 is the choke valve, number 3 is your test header, number 4 is your production header, number 5 is your drain system, and number 6 is your chemical injection system. There are 2 other things, those are not under our battery limits, so they basically go into the reservoir engineering limit, the 2 valves of triple SV and the double SV. So basically the subsurface safety valve and the surface safety valve, these 2 valves are coming out, are basically downstream of the wing valve, and they are basically in the reservoir, and they are also your emergency valve, that in case of overpressure case scenario, if this ZV fails, if this ZV does not protect the offshore oil platform, then this triple SV and the double SV will operate and they will cut down the reservoir production. That will be the last remedy or the jeopardy of that particular system, just to avoid the overpressure case scenario. This is all for today. Tomorrow we'll be discussing about the hydraulic calculation, that how these pipes are simulated and how we can calculate the hydraulic velocity and the pressure drop in that particular pipe. Thank you very much for watching the video. Please like, subscribe and promote this channel. Thank you very much.